we'll repeat it once again and for a better understanding, and we'll move ahead. So I'm also planning to include this topic in your syllabus. So which are in general called as ASM charts. Algorithm state machines drawing. It will be like a flow chart itself. It will be like more of a flow chart. So we can draw a state machine, state diagram, or ASM diagram for any of the given problem, from which we can extract HDL code, from which we can write HDL code and implement the given problem statement. So what I have told you in the previous classes, first of all, state machines, are they sequential circuits or combinational circuits?
Sequential, sir.
Only sequential, no sequential.
Combination part ఉంటుంది సార్.
Right. So we have two types of circuits: sequential circuits and combinational circuits. Now, can anyone explain what are sequential circuits and what are combinational circuits? What are sequential circuits and what are combinational circuits?
Combination circuit present input to present output. Present output depends on present input, sir. Combination.
In combinational circuits, output will be a function of, or present output will be a function of present input. Right. What about sequential circuits?
Depends. Present output is function of past input, sir.
Present output.
It depends on present input.
Right. Right. So present output is a function of present input as well as past output, as well as this is previous past output. So this is the definition of a sequential circuit, sequential logic. So in some textbooks it is written in this way. So present output will be a function of present input comma past output is represented as present state. To be more particular or to be more clear, function of next state, present input and present state. So in this way also it was written in two textbooks. Next state is a function of a present input and present state. Present state is nothing but the past output. This is what sequential circuit is, and combinational circuit is straight away the present output is a function of present input. What are the examples for combinational circuit? What are the examples for combinational circuits?
Adders, multiplexers.
Logic gates.
Adders.
Logic gate, multiplexers.
Is it a sequential or only purely combinational? Can we make it into sequential? Right, keep it aside. Multiplexer. Multiplier. Right, whenever registers are used. If it is a serial adder, then it won't be a combinational circuit. So serial adder is not a combinational block. Multiplexers.
Serial adder ante
We haven't discussed. We are supposed to discuss. No. Ripple carry adder and caryocate adder. These two are combinational only. So serial adder is not discussed. Serial adders will be discussed in this course. We'll discuss in this course. Serial adder will have the register also. And multiplexers, multipliers, gates with feedback or without feedback. Which one will be a combination block? With feedback or without feedback?
Without feedback.
Right. So you should not say that. So suppose if a circuit is present in this way, is it a combination circuit or sequential circuit? It is having only an AND gate and an OR gate. Is it a combination or sequential?
Sequential.
Sequential.
Right. It is a sequential only. But it is not having any flip flops, right? No flip flops and no latches, no D flip flop, no T flip flop, no JK flip flop, no SR flip flop, and no counters also, and no clock signal. Now, why again it is a sequential logic, sequential circuit?
అంటే పాస్
Feedback part.
Not out to bandit input చేస్తాం.
Right, because of the feedback. So whenever we have a feedback in one particular circuit, so it comes under the sequential circuit. That's it. You should not remember this thing. The definition of sequential circuit is not this. The definition of sequential circuit is this. The definition of sequential circuit is this. And this is not a definition of sequential circuit. That only if and only if flip-flop, the flip-flop is present in our circuit, then only it is a sequential circuit. Wrong. Only if the flip-flop is present, it is a sequential circuit. May or may not be. So in that way. So feedback path should be there. That is regarding the combinational and sequential. And after that, so state diagrams, what we have done is, so already, so we have gone through counters, where we discussed regarding the synchronous counters, and the discussion is also made in asynchronous counters. In both of these things, we have drawn state diagram. Now, what is meant by state diagram?
sequence of states.
Right, sequence of states. Now, what is the information that is provided by the state diagram? What is the information that is present inside a state diagram?
Present state, next states.
The information on present state, information on next state, and any other information? Any other information?
External input కూడా చెప్పచ్చు.
Okay, external. Next, any other information?
Total possible states.
Total possible states. Okay, next. Any other information? Present state, next state.
సార్ బిహేవియరల్ కండిషన్ కూడా చెప్తున్నా సార్.
What is meant by behavioral condition?
అంటే అది ఎలా వర్క్ అవుతుందని సార్.
Right, okay. Someone is saying that behavioral condition. Okay, next. Any other information?
Order of the outputs.
Right, sequence. Okay, next. Sequence of outputs. Okay, next. Any information that is present, any indirect information that is present in the state diagram, any information that is present, implicit information.
అంటే ఇన్పుట్స్ ఫ్లిప్ ఫ్లాప్ ఇన్పుట్స్ ఉంటాయి అంటే దాని నుంచి పని చేస్తాను.
Plus పనిచేస్తుంది. ఓకే. Any other
Present state next state.
present state next state we have written here. Present state next state.
అంటే
Any other
transition, sir.
right. State transition. State transition triggering. State transition trigger points. Right, I'll write in this way. State transition trigger points, which are nothing but the clock, a positive edge or a negative edge. Right. Any other information, right? We'll write it as an extra, etc. Random. And now, if it is a mod 4 up counter, just I'm revisiting the previous class such that you will be understanding the things more clearly, right? Mod 4 counter. Mod 4 counter in the sense how many states will be there?
4.
So 4 states will be there. How many flip-flops are required?
2.
Minimum number of flip-flops are 2.
2, sir. 2.
Minimum is 2. With 4 also we can do it, but minimum is 2. With the 2 flip-flops we can do it. Right. Now the 4 states, let those 4 states be in this way. 0 is my present state. Then after that, so 1 is my next state, next 2, next 3. This is an example for one simple state diagram. One of the simple state diagram. Now, if 0 is my present state, what will be my next state? If 0 is my present state, what will be my next state? So 1 is my next state. And if 1 is my present state, what is going to be my next state?
2, sir.
2 will be my next state. And if 2 is my present state, my next state will be 3. And if 3 is my present state, and next state will be 0. This is it. Now again, so one more thing here. Right, with respect to the clock signal, we'll mark the states all then.
Sir, account trigger positive edges.
No, with the negative edge also we can do it. What is there in that? Positive edge to చేయొచ్చు, negative edge to చేయొచ్చు. If we change the flip-flops or if we introduce some logic, then we can do it, right? Isn't it possible?
Possible.
No, we are not discussing asynchronous counters here. In asynchronous counters, so the positive edge and the negative edge, so changes the entire sequence. But when it is a synchronous counters, synchronous, it doesn't matter whether it is a positive edge or negative edge. Is it true? Is it true or
Yes, sir. అంటే మొత్తం సీక్వెన్స్ మీద డిపెండ్.
Right, అంతే మొత్తం సీక్వెన్స్ మీద డిపెండ్ అయి ఉంటుంది. Whether it is a positive edge triggering or negative edge triggering, it doesn't matter. In case of synchronous counters, Remember, it is only in case of synchronous counters. If it is asynchronous, then again we need to do a lot of changes, right? So if A0,
ఎసింక్రోనైజ్ కూడా అంటే మనం
no, asynchronous లో మనం కొన్ని చేంజెస్ చేయాల్సి ఉంటుంది. మనకు కావాలి అనుకుంటే we need to use a different kind of flip flops. Yes, different kind of flip flops, or else Q or Q bar తో ట్రిగర్ చేయాలి, అలాంటి కండిషన్స్ ఉంటాయి. బట్ ఈ సింక్రనస్ కౌంటర్స్ అయితే అలాంటి సిచ్యువేషన్స్ కూడా ఉండవు. సో 0 is my present state. Now when this 0 is going to, so this is the first clock, this is the second positive edge of the clock, the third positive edge of the clock, the fourth, so this is the fifth and sixth and so on. Right, after the appearance of the, so 0 is my present state, 0 is my present state. Whenever this positive edge occurs, after some delay, reality lo aithe delay antam, so we won't consider a delay here. So 0 is going to become what here? 1. 0 will become 1. Now, does this 1 become 2 immediately? 1 immediately 2 avutunda? What is the meaning of this? Right. So 1 will become 2 only at the second positive edge. Only after this. Only after this. If it doesn't occur, then 1 will be again 1 only. This will be 1 only. Then again 1. Then again 1. Then again 1. Whenever it is a positive edge, then it will convert into 2. After that, again 2. So again 2, again 2, and again 2. And whenever there is a next positive edge, 3, 3, 3, and 3, so on. Then again there is a positive edge. So positive edge, then it will be 4. A positive edge, then it will be 5. But we won't get 5. So here it is only 0, 1, 2, 3. So after 3, the next state will be 0. After 0, it will be 1. But most of the students will be they will be confusing, or they won't understand this particular logic. So this particular state diagram gives the information of the clock also. 0 is going to become 1 whenever there is a positive edge or whenever there is a negative edge. Depends upon the circuit. Depending upon the kind of circuit, it may be either a positive edge or it may be either a negative edge. Just a minute. Right. Can you see me? Am I audible?
Yes, sir.
Right. So the confusion is at this particular point. So in textbooks also, the state diagrams will be given, but so clarity will not be maintained on this particular clock, which is already present implicitly, and by default it is present indirectly. Indirectly, this information is available. So 1 will become 2 whenever there is a positive edge, and 2 will become 3. I mean, present states transition occurs whenever there is a positive edge, and here also positive edge. Now, if you doesn't know this particular information, when you doesn't know that particular information, you cannot write a Verilog code properly. You cannot write a Verilog code properly. Why? Because you are supposed to write inside the loops, you are supposed to mention that whenever there is a change, whenever there is a positive edge of the clock signals, then my present state and next state will be varying. That clarity needs to be maintained. That information needs to be understood by everyone. Now here in this particular diagram, so the next state is a function of next state is a function of
Present state.
right,
States.
only present state. So here the next state is a function of only the present state. We don't have any external inputs here. External inputs, external outputs are not present here. Then what we have taken is we have considered the another case also. This is also discussed in the previous class. Now, along with present state, now let us consider X input also. Let us consider external input. And let this be represented with the help of X. Let us represent external input with the help of X. And what it was said is whenever X is equal to 0, up counter or down counter? What is told for you? Right, up counter. And whenever X is equal to 1, this is going to be a down counter. Now up counter in the sense the sequence is 0, 1, 2, 3, and from 3 to 0. This is my sequence. And if it is a down counter, what will be my sequence? 3, 2, 1, 0, and after that again 3. So this is what it should be happen. Now for this state diagram will be given in this way. If I start with 0, 0 is my present state. What about the size of external input, whether it is of 1 bit or 2 bits?
1 bit.
Right. X, which is nothing but external input or present input, this is only of 1 bit. 1 bit in the sense, so X can be a 0 or X can be 1. It can be either 0 or it can be either 1. So X is equal to 0. X is equal to 1. Now whenever X is equal to 1, what is the next state?
3, sir.
So whenever X is equal to 1, the next state is 3. Whenever X is equal to 0, what is my next state?
1.
Whenever X is equal to 0, this is 1. Is this statement clear for all? So here, along with, assume that here also the counter is positive edge. Along with the positive edges, the external input value must be equal to 1. Earlier, it's only the clock. Now it is clock plus external input. Now, what is the trigger here? Trigger for present state and next state transition. Like a trigger and
2 to 1, sir.
external input plus the clock. ట్రిగ్గర్ అంటే ప్రజెంట్ స్టేట్ నెక్స్ట్ స్టేట్ ఎప్పుడు చేంజ్ అవుతుంది అని చెప్పేసి ఎక్స్టర్నల్ ఇన్పుట్ యాజ్ వెల్ యాజ్ ద పాజిటివ్ ఎడ్జ్ బోత్ ద థింగ్స్. Isn't it? Is it clear? External input plus clock, both the things are important here. Both the things are to be considered.
సార్
Yes.
అంటే ఎక్స్టర్నల్ ఇన్పుట్ ఇప్పుడు ఏదో ఒకటి ఉంటుంది కదా సార్, అంటే వాకే కదా మెయిన్.
But depending upon external input only, your state is defined, right? So external input 1 ఇచ్చినా అనుకో 3 వస్తుంది, 0 ఇచ్చినప్పుడు 1 వస్తుంది. See, earlier condition ఏంటి? What is the difference between the earlier thing and this? So in earlier case, it is purely only on based upon the clock signal. Just a clock వస్తే చాలు. Whenever there is a positive edge, then your state is defined. But here, along with the positive edge, you are supposed to define this also. If x value is not given, then randomly it may go to any of the next state. There is no compulsion that 0 needs to go for 1 or 0 should enter 3 if x is not defined properly. If x is not given properly, so we may get anything, right? 1 3 ఇంకేదైనా రావచ్చు. But here our circuit is designed in this way. Pine problem lo vachesi here we are defining our circuit in this way such that whenever the present state is 0 and if there is a clock edge, so it will be 1. ఇక్కడ అలానే డిఫైన్ చేస్తున్నాం. And ఇక్కడ కింద ఏం చేస్తాం, we have defined the value of the x also. X not this I mean the circuit is designed in such a way that there will be x also for this. So if this is the entire circuit diagram, so there will be a clock signal, there will be the value of x also. Inside this there will be flip flops. Ela untai. This is one flip flop and this is another flip flop. So x value must be given and clock value must be given. If this clock value is random value, if the clock value if the x value, external input value is random, make output ఏదైనా రావచ్చు. You may get the next state or you may get any other state also. Is it clear?
Yes sir.
See, this is clock. What is the output of this AND gate?
Clock.
What is the output of this AND gate? Same clock, right? Same clock. Now what is the output of this AND gate? What is the output of the second AND gate?
Depend on x.
It depends upon x, right? It depends upon x. It depends upon x and it depends upon this clock signal also. It is not that it depends purely on x or purely depends upon clock. It depends both on x and also clock. If x is equal to 1, what will happen? We'll be getting the same clock. If x is equal to 0, what happens? We'll be getting 0 value. The same the case here also. We have a clock signal and we have the x value. So whenever x is equal to 0, next state is 1. If x is equal to 1, next state is 3. If you give random values, you will be getting the random results. Is it clear?
Yes sir.
Right. Okay. Nice. Now, if my present state is 1 and if x is equal to 0, what will be my next state?
2 sir.
Right. So if x is equal to 0, if present state is 1 and if it is x is equal to 1, then if x is equal to 1,
0.
1, okay, right. This is 0. X is equal to 1, right. The present state is 3. If x is equal to 0, what will be my next state?
1.
present state 3, if x is equal to
0 సార్
0, right? X is equal to 0 అయితే ఏమవుతుంది?
0
If x is equal to 0, if we indicate in this way, is it right or wrong? Is the state diagram correct or wrong? Right or wrong?
అంటే 2 స్టేట్స్ సార్ ఆల్రెడీ 0 ఉంది.
Right. So remember this. Remember this. You are not supposed to rewrite. You are not supposed to repeat the same state. Same state మీరు మళ్ళీ draw చేయకూడదు. So already 0 is present here. You are not supposed to write down this particular state. So what you are supposed to do is you just redraw a line from 3 to 0. This happens whenever x is equal to 0. Right. Next, if x is equal to 1, what will happen? Present state is 3. If x is equal to 1, what will happen?
2 సార్
Right. X is equal to 1, it is 2. Have we covered all the states and all the possible inputs? X is equal to 0, 0 and 1, x is
చూడాలి.
equal to 1. Right, 2 చూడాలి. So if present state is 2, x is equal to 0, what will happen?
3 sir.
3 సార్
Right. X is equal to 0. Present state is 2, x is equal to 1, what will happen? Present state is 2, x is equal to 1. Right. Is it clear for everyone? Any doubts in this? So in textbooks, the same thing will be written in this way. Why we have taken 2 bits? Why it is 2 bits?
mod 4 కదా mod 4
Right, mod 4, 4 states. 4 states can be represented with 2 binary bits. 4 states can be represented with 2 binary bits. Now, what we have discussed is case 3 is include external output for above problem. Include external output for above problem. Include external output for above problem. That is, whenever my next state is equal to 3, output must be equal to 1. Right, this is the condition. So this is the condition. For all other cases, output value is equal to 0. Right. 0 0 0 1 1 1 and 1 0. This is for x is equal to 0 and this is for x is equal to 1, and this happens whenever x is equal to 0. This is for x is equal to 1. This is x is equal to 1. This is x is equal to 0. Right. So what is our condition? What we are saying? When output is equal to 1?
Next state is 3.
Whenever next state is equal to 3, right? So this is the case when x state is equal to 3. So here y is equal to 1. And where is the other case? This is the one, right? Here also y is equal to 1. For all other values, the value of y is 0. For all other values, value of y is 0. Y is 0. Is it clear? And finally, the standard way of writing down this is this. Can we draw the circuit without the arrow marks?
No, sir.
No, sir.
Why arrow marks are required?
అంటే సిగ్నల్ ఫ్లో తెలియాలి కదా.
ఏ తెలియాలి? What is to be known?
సీక్వెన్స్
Signal flow, right? Present state and next state. Which one is present state? Which one is next state? That is to be known. So this is written in this way. The numerator represents the input value, external input value. Denominator represents the output value. Right. How many of you have understood this particular state diagram? Any sort of confusions in this? దీంట్లో ఏమన్నా కన్ఫ్యూజన్ ఉందా మీకు? Any confusions in this?
No, sir.
Now what will be asked for you is, so design a circuit for the state diagram. For the state diagram, this one. For this, you'll be asked to design a circuit. So don't get confused with this. Praveen, are you online? Praveen, is he from batch 456? Hello.
Sir.
Yes, Praveen, are you online?
Yes, sir.
Have you, I think you have asked a doubt on this, right? Right, next state. Right. Present state. You may start with any of the condition. It is not like you are supposed to start with 0 0 only. I'll start with 0 1. So if my present state is 0 1, what will be my next state?
External input.
వాల్యూ తెలియాలి.
Right. It depends upon the external input also. It depends upon the external input also. It depends upon the value of external input, that is x. Okay. Right. If my external input value is equal to 0, what will be my next state?
1
0
0.
1 is my present state. 1 0 is my next state, right? What is the output?
0
0.
0, sir.
Right, perfect. Now I'll take a 0 1 as a present state, and if x is equal to 1, what will happen?
0, 0, sir.
0 0 is my next state, and what is my output?
0.
0, right? And if I consider 1 0 as my present state, and if x is equal to 0, what will happen?
1,
1
1, sir.
1.
What will be the output?
1.
1
Right. And 1 0 as the present input, and if input is x is equal to 1,
0 1.
0 1, what about the output?
0, sir.
0, right? Now if 0 0 is my present state, and if x is equal to 0 0 0 and x is equal to 0 0 0 x is equal to 0, what is my next state?
0, 1, sir.
0 1 is my next state. And what about output value?
0, sir.
0.
0 0 and x is equal to 1, what will be my next state?
1 1.
1, 1, sir.
Right, 1 1. What about the output condition?
1.
1, sir.
1. Right, now we are left with this 1 1 0, what will happen?
0, 0, sir.
0.
0, 0.
Right, 0 0. What about output is
0.
0 1 1? If it is 1, what will happen?
1, 0, sir.
1, 0, sir.
1 0. Output
0, sir.
Okay, perfect. We have present state, we have x values, next state, output. Assign variables also. Let this be q1, let this be q0, this is x, let it be q1 plus, let it be q0 plus, and let this be y. Let it be y. Now tell me, how many flip-flops will be there in the circuit?
2. Sir.
Right? Two flip-flops are to be used, and it is our own choice whether to use D flip-flops or JK flip-flops or T flip-flop, positive edge or negative edge. Everything is up to us. What shall we consider here? D or T?
D.
Which shall we consider? D flip-flop, right? So let it be D1, let it be Q1, let it be Q1 bar, and the D0, Q0 and Q0 bar. See, these are not known. The D0 is not known. D1 is not known here. అవి రెండు మనకు తెలియదు. D1 is not known and D0 is not known. Now how to get the values of D1, D0?
Excitation table.
Right, perfect. With the help of the excitation table, which is nothing but the other form of characteristic table. Now the characteristic table of D flip-flop will be in this way. So the value of D, the value of Q, the value of Q plus 0, 0, 0, 1, 1, 0, and 1, 1. Whenever D is equal to 0, Q is equal to 0, Q plus will be
Qn.
right.
0.
So 0, 1, what will be the value of Q plus?
Qn.
Qn అవుతుందా?
D.
0 అవుతుందా? 1 అవుతుందా?
0.
It will be 0, right?
0, sir.
Data flip-flop, D flip-flop, whatever the data that you give, the same data will be copied. So here this will be 1 and here this will be 1. Now, if you redraw the same truth table in another way, in this way, Q plus and D, Q plus and D, if we redraw in this way, 0, 0, 0, 1, 1, 0, 1, 1, Q is equal to 0 and Q plus is equal to 0. Q is equal to 0 is present over here. Q plus is 0 here. What is the value of D in value?
0, sir.
Right. So Q is equal to 0 and Q plus is equal to 1. What about the output in D value?
1, sir.
1.
1. So this is 1 and 0. What will be the value of D in
0,
value?
0.
0 here.
0.
1, 1. What will be the value?
1.
1, 1. Right. 1. So 0, 1, 0, 1. Just with the help of this is called as excitation table. This is called as characteristic table. Okay, right, perfect. So what will be the value of D1 here? For D1, so we are supposed to compare Q1 and Q1 plus, and for D0 we are supposed to compare Q0 and Q0 plus. Now tell me what is the value of D1 here? What will be
1,
the
sir.
value of D1?
1, sir.
So this is 1. What about this? This will be 0.
Zero.
This is 1. This is 0. This is 0. This is 1. This is
Only
0 and
one.
this is 1. Right. What about D0?
0, sir.
0 and this is 0. This is 1. 1, 1, 1
One.
and 0 and 0.
Zero.
So you obtained a D1, you obtained a D0 also. Now write down the minterms for D1 and D0. So D1, which is a function of Q1, Q0, X, this is equal to sigma M of, write down the minterms for D1. What are the minterms for D1? What are the minterms for D1? D1 minterms and
1, 6.
this is one particular minterm. 0, 1, 0. What it is? 1 అవుతుందా?
M2, sir.
Right, it is 2, right? It is 2. First లో ఉన్నది ఎప్పుడు minterm 0 అవ్వాలని లేదు. We are not following the sequence here. So conceptually it is equal to 2. Then again, this is another case. And again we have another case here. We have another case here. Right, tell me. 2,
4, 1, 7.
4, 1 and 7. And what about D0?
Zero, 1, 4.
What about D0? 0, 1, 4 and 5. What about Y? Output Y. Y is also function of Q1, Q0 and X. What about this?
1,
1 comma?
4, sir.
Right. So 1 comma 4. Right, perfect. And with this, we will be getting the expressions and we will be making out the problem. Now, a simple task for you is, can you draw state diagram for D flip-flop, JK flip-flop, T flip-flop, assuming next state as output. Can you draw the state diagrams for D flip-flop, JK flip-flop, T flip-flop? Can you do it?
Yes, sir.
Right, then do it. Chain. Everyone, I request every one of you to solve this problem. Write down this, draw the state diagram for a D flip-flop, for a JK flip-flop, for a T flip-flop. The characteristic table for D flip-flop will be in this way. If we did not mention the clock value, we can assume that the clock is simply a positive edge or negative edge. Dn, Qn plus 1. Output value y. Right. So whenever D is equal to 0, Qn 0, what is the value of Qn plus 1?
0, sir.
D is equal to 0, Q is
0, 1.
equal to... Is it 1 or 0?
0, sir.
0.
This is 0. Next.
1, 1, sir.
1.
100. Now, based upon this particular condition, I am writing this as 0, this as 0, this as 1, and this as 1. Is it okay? This is purely an assumption. You need not ask how this is equated. Next state is equal to output ఎక్కడి నుంచి రిలేషన్ వచ్చిందంటే ఎక్కడి నుంచి రాలేదు నేను రాశాను. It's purely an assumption. You may assume anything. మీరు ఇంకేదన్నా కూడా అనుకోవచ్చు. Assuming y is equal to next state. Right. Only state diagram. I don't want implementation of this. What is the external input here? What is the external input here?
D.
What is the external input variable? ఏంటి?
లేదు సార్.
లేదా external input.
D.
Now, how you are saying that there is no external input? ఎవరు చెప్పింది అది?
అంటే సార్
Who said?
కాకుండా
You did not hesitate. Just let us discuss. That's it. Right. ఎవరు చెప్పింది అది? Hello? Who said that?
వీరబాబు సార్.
రైట్ వీరబాబు, డిస్కస్ చేద్దాం. నువ్వు హెసిటేషన్ అలాంటిది ఏం ఫీల్ అవ్వాల్సిన అవసరం లేదు. ద రిమైనింగ్ పీపుల్ ఆర్ నాట్ ఓపెనింగ్ దేర్ మౌత్ ఆల్సో. రైట్, వెదర్ ఇట్ ఈస్ రాంగ్ ఆర్ రైట్, సే సంథింగ్. యూ షల్ డిస్కస్. ఇఫ్ ఇట్ ఈస్ రైట్, దెన్ it's okay. If it is wrong, then also it is okay. Right? Why it is? Why you didn't get any external input here? Only states I1.
అంటే
And
ఇది
some
అంటే కౌంటరే కాదు
right.
సార్ అంటే
కౌంటర్ కాదు నేను చెప్పింది. సో అందుకని కాన్సెప్ట్స్ వెళ్ళొద్దు. సి అలాంటి కాన్సెప్ట్స్ పెట్టుకోవద్దు అని చెప్పేసి అన్నా నేను. Some people what they will be memorizing is, so what is meant by sequential circuits? They will say that flip flop is a sequential circuit, latch is a sequential circuit, and next, so register is a sequential circuit, asynchronous counter is a sequential circuit, synchronous counter is a sequential circuit. Is this thing wrong? Is it wrong? Flip flop sequential circuit kada? Is it right or wrong?
yes sir sequential circuits
Right, it is right. So nothing wrong in this. But instead of this, if we generalize and if we say that, so whenever there is a feedback element, or whenever there is a memory element in my circuit, then it is called a sequential circuit. What about this? Is it right or wrong? Is it wrong? Feedback element
Right.
into sequential circuit. This is also right. So there are two ways of understanding and identifying the things. So if this is the first way and if this is the second way, say the first way specific గా గుర్తుపెట్టుకుంటున్నాం. నాకు flip flop కనిపిస్తున్నా నేను sequential circuit అంటా. And in exam, if a question which is given in this way, we will ask this: is this a synchronous? Is this a combinational circuit, or is this a sequential circuit, or none of the above? అని అంటాడు. So you people will be placing it as a combinational circuit. Why? Because NAND gate ఒకటి ఉంది కాబట్టి కాంబినేషనల్ పెట్టేశారు. కొంతమంది ఏం చేస్తారు? So they will be keeping it as a none of the above. But from this particular understanding, అది ఎప్పటికీ sequential circuit కాదు. Why? Because no, it is not a flip flop, it is not a latch, it is not a register, it is not a synchronous counter, it is not a synchronous counter. So and hence this is not a sequential element. But if you take this particular definition, then what will happen? Apparently,
sequential circuit
then it is a sequential circuit. Then it's sequential circuit. So things are to be understood in this way. So that is the reason. మీకు ఇక్కడ పైన ఎక్కడన్నా కానీ కౌంటర్ అలాంటిది ఏమైనా చెప్పానా? Right. Mod for up counter అన్నాను. After saying it as a mod for up counter, then after that, so what are the things that I have told for you? Present state, next state, present input. ఇవే కదా యూజ్ చేస్తుంది. Right, I will erase this. ఇది erase చేస్తా. Then అది erase చేస్తే then is this a state diagram or not? State diagram కాదా? Is this a state diagram or not?
Yes, sir. Stated.
Then also it is a state diagram. But mod for counter అనేది name లేదు. So state diagram is the one which is going to give us the information regarding its present states, next state, external inputs and external outputs. అది మాత్రమే ఇస్తుంది. The definition that is already given by you people: present state, next state, external inputs, total possible states, behavioral condition, sequence of output, state transitioning, triggering points, etc. So that is the information which is given by this. So whenever x is equal to 0, if my present state is equal to 1, next state is equal to 0. If x is equal to 1, 0, next state is equal to 2. Now see this, the problem that is given for in front, which is present in front of us. right? This is my input. Qn is my present state. Qn plus my is my next state. This is my present output. Now can I consider Din as my present input? Consider cheyocha. Din my present input ga. It is an external input, right? An external input, it is not a state. See, you need to have only two things. Whether it is a direct input or it is a state. ఇవి రెండే ఉండాలి, ఇంకేది ఉండదు. Either it is an input or a state. Output దగ్గరికి వస్తే, so output or a state. Or a state. So input side అయితే దీన్ని present state అంటాం, output side అయితే దీన్ని next state అంటాం. That's it. So across the input you will have input and state, across the output you will have output and next state ఉంటుంది. So Din is nothing but a state only. Sorry, Din is nothing but the input value. Din is nothing but the input value. When Qn is my present state, Qn plus 1 is my next state, Y is my output. Just Y is only an assumption. Y will not be present in D flip-flop. Right. So how many states are present here? Total. It's Japan now first. How many states are present in this particular state table? 2 or 4. Why 4? 4 అని ఎలా అన్నావు? 4 states అని ఎలా అన్నావు?
అంటే ఉన్నాయి
Only 2.
Q1
Q1 అంటే 0 ఉంది, Q1 అంటే 1 ఉంది. Right. Okay. Accepted. Let's see this. How many states are present here?
4 sir.
4, sir.
Right. Whenever it is 4, so this is equal to 0 0, this is equal to 0 1, this is equal to 1 0, this is equal to 1 1, and this is Q1 Q0 notation. Right. Now tell me how many states are present here. How many states are present here? Any states ఉన్నాయి? Total states.
2, sir.
2 is
No, let everyone
Two,
clear
sir.
this. Only 2. Why only 2? 2 అని ఎలా అంటున్నావు?
అంటే ప్రజెంట్ స్టేట్ నెక్స్ట్ స్టేట్ 1 బిట్ కదా సార్.
Only 1 bit. See, Q is only of 1 bit. So Q values ఏమున్నాయి చూడండి అసలు ఇక్కడ. Q values మీకు ఎన్ని కనిపిస్తున్నాయి ఇక్కడ? What is the Q value here? What is this?
0 సార్.
What is this?
1 సార్.
Right. What is this again?
మళ్ళీ 0 సార్.
ఇక్కడ ఎన్ని ఉంది?
1 సార్.
1. Only 2 states ఏ కదా? See, if I write in this way, so this is myself. This is Dattatreya. Now tell me how many different names are present here.
3 సార్.
Is it 1, 2, 3, 4, 5 అవుతుందా? No, it is only 3, right? This is the one, this is the next, this is the one, this is again repeated, this is again repeated. So only 3. So here also the total number of unique states are only 2. 0 అనేది ఒక స్టేట్, 1 అనేది ఇంకో స్టేట్. Is it clear? Is it clear?
ఎస్ సార్.
Right. Right. Okay. Okay. Or to be more clear, let us name it as S0. Let us name this as S1. Let us name this as S0. Let us name this as S1. 0 is represented for, 0 is represented with S0. 1 is being represented with S1. Right. States law. Now what is this? Is this an S0 or S1? S0 or S1?
Yes, not, sir.
This is S0. What about this? This is also S0. What about this? S1.
Yes,
This is S1. Right? So you have given some naming conventions over here. So 2 states are present. One is S0, another thing is S1. These are the two states. Now S0. We are at S0. This is my present state. And if dn is equal to 0, what is my next state? If dn is equal to 0, what is my next state?
0. Same
Not
answer.
Right,
Yes,
the
not, sir.
same
Yes,
state. So whenever d is equal to 0, right? Now whenever d is equal, sorry, right. Now my present state change it to S1 ki వెళ్ళిపోతున్నా. S1 is my present state. Now this is not my present state, this is my present state. S1, I am available at S1. This condition, second condition. I am present at S1. If d is equal to 0, what will be my next state? If d is equal to 0. If d is equal to
Yes.
0, right? If d is equal to 0, this is going to happen. If d is equal to 1, what will happen? Right, అది మళ్ళీ మనం వద్దాం.
Same state, sir.
Right.
Same
We'll come, get to it later. Now the present state is yes naught. D is equal to 1. What will happen? Present
Yes, sir.
state is S naught and D is equal to 1. The next state is S1. Present state is S1 and D is equal to 1. What will happen?
Yes, sir.
Again, it will be.
Right, again S1. Right. Any difficulty in this?
Yes.
Any difficulty in this? So this will be given in GATE exam for 1 mark or sometimes for 2 marks also. Identify the state diagram for a D flip-flop antadu. Identify the state diagram for a D flip-flop. Just 4 multiple choice questions is there, and he will be changing the values of D's here. Right. We have output also, right? Mark output also. Output remark cheyandi. For this, what is the output? S naught D is equal to 0, the same S naught. What is the output here?
0, sir.
0.
Right. Next, what is the output here? S naught D is equal to 1. The next state is S1. What is the
1,
output?
sir.
1, sir.
Right, 1. Now, present in S1, input is equal to 1. What is the output?
1, sir.
1, sir.
1 set.
Right. And what about this? This is equal to 0.
0.
Right. This is nothing but a state diagram of D flip-flop. State diagram of a D flip-flop. Now let us draw the state diagram of next. If you are drawn, you may recheck your answers. State diagram for a T flip-flop. The value of T input, value of Qn, value of Qn plus 1. Here it is y. Now y is equal to next state. 0, 0, 0, 1, 1, 0, and 1, 1. If you cannot remember these things, I am completely I won't be in a position to help you in any way. Right. Now what is the value of Qn plus 1?
0, sir.
This is 0. What about this?
1 and 1, sir.
Whenever t is equal to 0, this is 1. What about this? This is 1 and this is 0. This is also assumed as 0, 1, 1, 0. Now, in this, what is the external input value? Is this? This is my external input. This is my present state. And this is my next state. And this is present output. Is this clear?
Yes, sir.
Is this clear?
Yes, sir.
Right. Can you tell me how many different states are present in this problem?
2, sir.
2, sir.
Here again 2. See, don't number of states ante ila chudakande. Some people will be seeing in this way 0 0 1 1 0 1 1 0. Sir, 4 states ఉన్నాయి కదా అని చెప్పేసి. Not in that way. You are supposed to check only with the present state column. Present state column is to be verified. That's it. So this is one particular state. If it is S0, so this is also S0. And next, if this is my S1, this is also my S1. Right? The same values can be submitted here also. This is S0. This is S1. This is S1. And this is my S0. Is it clear regarding the identification of the number of states in a state transition table? State table or the number of states anedi where you are supposed to say check. Hello.
Yes, sir.
Yes, sir.
Right. So in only in the present state column you are supposed to check. Only in the present state column you are supposed to check. Now here also the same thing. If 0 1 is my S0 condition, this is also my S0, and if I name this as my S1, this also will be my S1, and this will be my S2. This is also S2. This is S3, and this also will become S3. So 4 states in that particular problem, which is a mod 4 counter, and here it is only 2 states, right? Right, S0, S1. If t is equal to S0, if t is equal to 0, what will be the next state?
0.
Same state.
0, sir.
Same state. T is equal to 0. S0, if t is equal to 1, what will be the next state?
1,
Yes,
sir.
sir.
Right. S1 state. If t is equal to 0, what will happen?
Just one.
Yes.
Right. If t is equal to 0, what will happen?
T equal to 1, sir.
I am present at S1. I am present at S1. If t is equal to 0.
Same state.
S1, if t is equal to 1, what will happen?
0.
0.
Yes, 0, sir.
So this is 0, this is 1, antena?
Yes, sir.
Yes, sir.
Right. Now what about the outputs? Tell me the outputs.
0.
What is the output here?
0, sir.
Now what about the output here?
1, sir.
What about the output here?
1, sir.
What about the output here?
0, sir.
Right. Now this is T flip-flop state diagram. T flip-flop state diagram. Any doubts in this? Any doubt in this? Is it clear? Shall we move on to the next?
Yes, sir.
Hello. All right, this will be my the last discussion today. JK flip-flop. The value of J, the value of K, and the value of Qn, the value of Qn plus 1, and the value of Y. Now tell me, whenever j is equal to 0, k is equal to 0, q is equal to 0, what will be the value of q plus?
0, sir.
0 sir.
0 sir.
What about this?
1
1
sir.
What about this?
0.
0 sir.
This is 0, this is
0.
0, this is 1,
1 1.
this is 1, and
1
this
0.
is 0. Right, this is 1, 0, 0, 0. Right. Now tell me how many states are present here?
2 sir.
2 states.
2 states. Right. So this is S naught. This is S naught. This is S naught. This is S naught. And this is S1. This is S1. S1. This is S1. Right. So this will become S0. This is S1. This is S0, S0, S1, 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 and S0. Right. Perfect. Now you can name it as A, B also. S not S1 అలా కాకుండా A, B అని కూడా పెట్టుకోవచ్చు. Your wish. S naught and S1. Right. Initially at S naught, if a 0, 0 is are the input, what is the output?
S naught sir.
S naught. If 0, 0 is the input, S naught. What is the output?
0, sir.
0 sir.
Right. Okay. Now the next condition. We'll take up the next condition. So I'm located at S1. If 0, 0 is my input, what is the next
S1
state?
sir. S1.
Right. 0, 0 is my input. Next state is the same S1 with output as 1. Right. S naught is my input. If 0, 1 is my input, what is the 0, 1 is so
S naught.
0, 1
S naught sir.
the same S naught. What about output?
0
0
sir.
or 1? 0, right, perfect.
0.
Now next is S1. S1. S1 0, 1 condition. What will be the next state?
S naught sir.
Right. 0, 1. What is the output?
0, sir.
0 sir.
Right, okay. Now I am present at S naught. 1, 0 is my input. 1, 0 is
S1
my
sir.
input.
S1.
Next state is S1, right?
S1.
1, 0. What is the output here?
1,
1
sir.
sir.
1, right. Next, which condition? 108 S1. 108 S1. S1 state 10 దగ్గర ఉన్నాం. What will be the next state?
S1. S1 sir.
1,
Right. Output will be 1.
1.
1, 1, and input is S0. Right. Input is 1,
S1
1. So it is 1, 1. What will be the output?
S1 sir.
Sorry. So 1, 1. What will be the output?
1, sir.
S1.
1, right. Now S1, I am available at S1, present at S1. If 1, 1 is my input, what is the next state?
0,
S0.
Right, 1, 1 with 0. Right. So this is JK, flip-flop state diagram. Is it clear how we have written? How we have written? Now yesterday
Yes.
we have seen the problems where the state diagram is converted to state table, and today we have seen the problems related to state conversion of state table to state diagram. Is it clear?
Clear, sir.
Yes sir.
Is it clear? Number of states ఎలా చూడాలి, స్టేట్ డయాగ్రామ్స్ ఎలా రాయాలి, ఇన్పుట్స్ ఏంటి, అవుట్పుట్స్ ఏంటి, all those things. Right. If that is clear, I want you to write down or implement this. I want a circuit diagram for this. This is not required now. Only this is required now. I want you to write down, draw the circuit diagram for this problem. How many states are present here?
4.
4.
Four
Four,
states.
sir.
Right. Okay. So, shall I close the class? Any doubts?
Sir.
Yes, tell me.
Sir, D morning again.
Decode నేను తర్వాత చెప్తాను. In this, any doubts in this? Only up to this part. ఇంకా నెక్స్ట్ లెవెల్కి వెళ్ళకండి. We haven't discussed melee machines. We haven't discussed more machines. That we will be discussing, and I will be clarifying your doubts after that. At present, conversion of a state table to state diagram and state diagram to state table. Is it clear? Are these topics clear? So, state table to state diagram and state diagram to state table. Up to this part, is it clear? With external inputs, with outputs. ఇక్కడ వరకు doubts ఉన్నాయి. Any doubts? So shall we close? Right, I will be leaving the session. Thank you.